Okay, so we're going to try to take the derivative of this function f of t equals the quantity t squared over t, this is cubed, t cubed plus 2, the whole quantity squared. So as we look at this, hopefully you can see that this is a chain rule. Here's the outside function, pretending just for a second that this is x right here. So we have x squared, and we take the derivative of the outside, wouldn't we? But we also have to take the derivative of the inside. So just as a way to remind you that the chain rule is that dy dt of f of g of t is equal to f prime at g of t, that's the derivative of the outside, right, times the derivative of the inside. So the derivative of the outside, I think, James, is really straightforward, I think, isn't it? I'm going to take this 2, bring it forward. 2 times 1 is 2. That's this 2 right here, right? We're going to decrement this exponent. That is, we're going to reduce it by 1. So 2 minus 1 is 1, and that's this exponent of 1 that would be right here. So this part right here is the derivative of the outside. That is to say, it's f prime at g of t. Now here's where we get kind of to the harder part, because then we get to the derivative of the inside. And the inside is this piece up here, this d squared over dq plus 2 quantity, not quantity squared, just this inside piece. So if you look at this, this is a rational, isn't it? So I'm going to take this and just going to make up our list here of the derivative of the inside, realizing that we're going to use the quotient rule. So I'm just going to take these pieces. The top part we're going to call f of t. So f of t is t squared. And then if we take the derivative of t squared is, that's right, isn't it? And then the bottom part we're going to call that the g of t. So g of t is t cubed plus 2. So g prime at t, Zach, is 3t squared. Don't you agree? Okay. And then from there, if you don't mind, just going to start trying to use this. Rule here. And here is the quotient rule, if you don't remember. The quotient rule is that dy, in this case dt, of f of t over g of t is equal to this mess here. Is that right? So this is g of t times f prime at t, and we already got all these pieces, and now we're going to go through here and we're going to fill in the blanks, and that's all I'm doing right here. Remember, we're looking for this inside function here. We're looking for the derivative of this. So we're just going to take these pieces and put it together. It's g of t, well, g of t is this. F prime at t, well, f prime at t is this. This negative sign right here, Dylan, is this negative sign right here. This one here is this one right here. F of t is t squared. G prime at t is 3t squared, so I'm going to multiply those two things. And remember, it's the whole thing over g of t quantity squared. So I'm going to do that. Hello. So if we do all this, Dylan, if we multiply all this into here, we end up getting 2t to the 4th plus 4t, and the 4t comes from 2t times 2. Multiply this times this, we get negative 3t to the 4th. We're going to simplify again. We have negative 3t to the 4th here, positive 2t to the 4th here. So when we combine them, we get negative t to the 4th. This positive 4t is this one right here. So far, so good. And then the whole thing over this. So when I got this thing simplified, believe it or not, we're almost there. We're going to have to start putting our pieces back together. So that's this. So if you remember from the very top we had this little bit at the top, didn't we? We had f prime at g of t times g prime at t, and we already had this piece right here. But we were missing this piece. So we went through all this here to create this piece. And if you look here, we created this piece, g prime at t is equal to this, and that is this. And if we multiply this piece times this one, because it's f prime at g of t times g prime at t, we get this, don't we? So far, so good? I think so. And remember, if you're going to multiply t cubed plus 2 to the first power times t cubed plus 2 to the second power, we add the exponential values, and that's where this 3 came from here. So believe it or not, we have this derivative. And the derivative, this is f prime at t is equal to negative 2t cubed times the quantity t cubed minus 4 over t cubed plus 2 quantity cubed. It's a lot of stuff. Hopefully what we're getting is that we're building these pieces and realizing we're building pieces over here that we're going to bring back over and add to the pieces that we already had. So it's kind of a big process. So we use the chain rule and the quotient rule, right? All right, let's try this really quickly if you don't mind. Let's try this on our calculator and see if we get the same answer. Okay, so here we are at your CAS calculator. You're going to go to your pull-down menu, look for calculus, and then take the derivative. Remember that we're looking for f prime at t, so we don't want ddx, we want ddt. It's really important because if you mix them, your calculator will tell you 0 or will tell you no answer. Here also, if you don't mind, I'm going to put some parentheses inside these parentheses because we're going to take a rational and then we're going to take that quantity squared. So we need to, and I'm going to control division, and I think we have t squared at the top. Is that right? Over t cubed plus 2. Now this is really important that we want to go outside these parentheses here. We're not outside them yet, so we want to be outside those parentheses. See the difference, Dylan? And we want to be inside it, because if we do, it's only going to square this. We're going to square the whole quantity. So then square that and hit enter. And is this the same derivative that we had? Yeah, take a second and check that. I think it is, isn't it? Yes. I think we're done. Yeah, we can definitely go back.